there, I wanted to show you the partial sums addition problems, and for these particular problems, they can be called partial sums, but in our classroom, I like to let the kids name them, and so sometimes on my website, you'll see what's called the break apart strategy, and you'll also see vertical addition. Both of these represent the problems a little bit differently, but they all are partial sum addition problems. So what I'm going to do is go through a problem and show it to you in a couple different ways. You can see it in both how we represent it as break apart and how we represent it as vertical addition, but they're all partial sum addition problems. Alrighty, to get started, we're going to start with this number. So 298 plus 345, and we're going to add those together. For the break apart strategy, I often teach students to expand both numbers. So 200 plus 90 plus 8, and then 300 plus 40 plus 5. And then they will add each of the place values. So 8 plus 5 is 13, 90 plus 40 is 130, and 200 plus 300 is 500. And you'll notice that students don't have to regroup this into the tens place until they're adding it over here. So most of the time, this will not require students to have to do regrouping using the traditional algorithm. Now, if students can put these together in their head, looking at each place value here, they can just write the answer over here. If they need to, they can write the place value sums vertically and then add those together. And what you will notice is that this looks very similar to vertical addition. So doing this problem using the break apart strategy is this piece here, and then they add it together. If we were to do it using vertical addition, I'll just change colors and write it down here for you. They would add either from the left or the right. Oftentimes the partial sum comes from the left. If you can also do it from the right, it does not matter which side you start on. And that's one of the benefits of using the partial addition strategy or the vertical addition strategy, is that it is versatile because you are not regrouping within, like you do with a traditional algorithm. You're doing it at the end as you are adding. So if I were to, this one kind of shows it from the left-hand side. If I were to do it from the right-hand side, I would add 8 plus 5, which equals 13. And I would think 90 plus 40 is 130. So 13, and then that 0 placeholder goes there. Or you can say that the 9 and the 4 in the 10th place. So it's 13, and it has to end up in the 10th place with a 0 placeholder. Same thing here, 200 plus 300 is 500, and it has to be in the hundredths place because that's the place that you are adding. And so you can see that there is a similarity between both of these, whether or not you're starting on the left-hand side or the right-hand side. Again, you are just adding these together and coming up with the answer. So I like to show all of these to students because they are different ways of representing the problem. If students need a little bit more assistance in decomposing the number or breaking it up into its place value using expanded notation, they can use this method, and it allows students to write down and focus on just each place value. This is helpful for kids who get lost in all of the numbers over here with a traditional algorithm, or who have difficulty what's called carrying or regrouping that one. This is helpful for kids who want to go from left to right, and then they can just work the problem from the largest place value to the smallest place value. And this is very similar, but it's working from right to left. They all are what's called a partial sum addition problem or a addition strategy because they break the number up into the place value. So a place value strategy, partial sum strategy, as I said, I like to call it a break apart strategy or vertical addition.